Hopefully as you work through these, maybe you're starting to see the pattern. Maybe it's hopefully becoming a little bit routine. There's a lot going on in this wave optics stuff to derive the equation, and maybe the concept is hopefully understandable. The extra distance, if it's a multiple of lambda or off by a half. If worse comes worse, hopefully you can get to the point where you can like plug and chug, find the values and plug them in where they go. For this one, our lambda was given as 450 nanometers, so 4.5 times 10 to the negative 7 when we're in meters. The screen is 2.5 meters away, that's our capital L. The distance between the first and fifth bright spots is 12 centimeters. I'm always going to draw it. I'm going to draw a bunch of these smudges. When I draw it, the smudges represent where there is light. If this was my first dark spot, this would be the second, third, fourth, fifth. So I've been given that this distance all the way across there is 12 centimeters. If that distance is 12 centimeters, that means that this distance is also 12 centimeters. That distance is going from the reference line, or the n equals 0, to the n equals 4, because I've shifted it over, n equals 4, since I've shifted it over 1 to the left. So in my equation, I can use n equals 4 with the y value of 12 centimeters. Or I could take a look, and this could be subdivided. I could switch it and say that instead of n equals 4, I could do n equals 1, and the distance from bright to bright is 12 divided by 4. I could use n equals 1 with a value of 3 centimeters, or I could use n equals 4 with a value of 12 centimeters. Whichever way you like better, we'll agree on the answer when we get to the end. I'm going to use the n equals 4 method. In this equation, we know everything but the d. I'm going to flip things around this time. So we've got n times lambda times L, and y gets flipped to the denominator. Our n was 4, our lambda was 4.5, L was 2.5, and the y for when I'm using 4 was the 12 centimeters. Crunching all that out, I get the small number of 3.75 times 10 to the negative 5. So 37.5 micrometers. We don't have to convert it. It's okay to just leave it in scientific notation in meters. Hopefully they're getting a little bit more comfortable.